All right. So real quick, the some nomenclature on class diagrams. Make sure that we're all on the same page on how we're going to capture UML class diagrams. You might have already seen this in OOD or somewhere else. So this hopefully is a review, quick review for you. So class diagrams are part of the of one of many different diagrams in UML. UML as a universal modeling language that allows you to have a common dialogue with other engineers, and ideally we would have a non technology specific graphical universal language, right, that we can all understand without having to specifically know Java or C# or VB or whatever, right? That we can all have a common language. So UML is by far the one of those types of languages that is pretty well understood by many. It has object-oriented fundamentals. There's tons of features in UML class diagram that are maybe sometimes a little bit too advanced, that are not actually yet implemented by any one particular language. But languages are trying to always see how they might implement many of these object-oriented ideas that were invented way back when, and are not necessarily entirely implemented in formal languages. So a class is going to be is going to be and just like a schema, explaining what are all the data points or data sets that are contained or collected in one single entity. It'll have a name of a class plus the names of the attributes in there, all the data types. Usually when you're implementing these in Java or programming language, the class diagrams will also have listed not only the attributes but also the methods, right? With whether they're public, whether they're protected, or private. So for this for implementing the data model, we don't really care about those actions, the functions or methods that go along in the class diagram. We only really care about the attributes. Okay. So the formal way of representing is that you have the name of the class, you have the attributes at the top, the methods at the bottom. For data modeling, for us, we're not going to be using the methods. Right? So if you leave it empty, that's perfectly fine. We do want to capture the attributes and their data types. We don't necessarily need any of the access modifiers, the plus, the hash, and the and the minus. That tells you whether something is public, private, or protected. We're going to assume that everything is always private. Okay, and only specifically you might say where something is protected or not. Some of the attributes might be optional, whether you have a date of birth or not. Have a date of birth or not. Maybe you're dead or haven't born yet. So the 0 or 1 means that you might have a date of birth or not. So that multiplicity tells you how many instances of that particular data value you might have in a single instance. And all the built-in data types are there: string, integer, boolean, double, date, time, and whatnot. For a person, maybe this was date of hire. Maybe that's what it meant. When I hired you, maybe that's what it meant. And so this multiplicity is notice that it's being applied to the attribute itself, not the multiplicity you might have between two records, right? So like a phone number, right? If you have many phone numbers, you might have an array in there of how many phone numbers you might have, or emails or whatnot, right? Instead of an array of those. Although we're gonna abandon the multiplicity that is certainly UML allows you to capture arrays, and obviously programming languages obviously allow you to have attributes that are multi-valued. Yes. But in SQL, there's the support is not across all the vendors. So typically, if you have a multi-valued attribute, typically what you'll have, you'll convert that and reify that as being a completely different table that is keeping track of all those values, right? A separate table as opposed to inside of the attribute. Right? So multi-valued attributes will typically be reified into separate tables. Enumeration typically many SQL vendors will support an attribute which could be of type enum, right? And that just like in a programming language, right, you can declare some enum and then provide the actual values of that enum. Yes. We're not going to use the vendor-specific enum implementation. Instead, we're going to use this other implementation. There will be a separate class, dedicated class, right? That's going to have what is called a stereotype enumeration. Right? Notice the pointy brackets up there, right? That means that UML. When they were designing UML and coming up with the idea, they said, well, how can we have UML evolve over time and be forward compatible? Right? We can't think of everything. Can we make a feature of a language that allow you to, if you come up with a brand new idea that is not represented in the language, how can we represent it? So they came up with stereotypes. So stereotypes allow you to take something that looks like a class diagram and add a tag that means something to you, whatever it means to you. Enumeration is one example of that. Right? So enumeration, that looks like a class diagram, and yes, it's implemented like a class. But down below, this horror, comedy, sci-fi, fantasy, typically these would be attributes in a class. Yes? But here they're not. They're not an attribute. Instead, this is just saying that there will be a variable that could be of type movie genre, and the only possible values for that variable are these four values. That value of genre can only possibly be either horror, comedy, sci-fi, or fantasy. Make sense? Right? There are already a lot of standard enumerations that are already implemented in class diagrams, like integers. That is an enumerated data type. It's a very big enumerated data type that goes from like minus infinity to plus infinity. Right? Those are all the valid values of all the integers. Yes? And just like dates, all the possible dates between beginning of 1970 and whatever, all those are the possible values of the enumerated data type dates. Make sense? But if you can think of other data types, right, then you can create your own. Right, so like genre is a new data type, and you can declare variables of that data type. So we'll see how to implement this using SQL. Typically, they're implemented with its own table, and that table has it's treated differently like any other table. Typically, in a table, you treat it as in records, right, that have all the same values, yes, and you can add and remove and update values in those records. Enumerated data types, they're not. They're meant to be static constants, right? That those are the only possible values, and they're not going to change ever again. Those are the only possible values, like the states. You would list all the states, yes, and hopefully nobody secedes from the United States anytime soon. Those are always going to be the same 50 some odd states, yes, and that's not going to change anytime soon. So same thing here, right? You would create a list of all the valid values, and they would be used for populating drop-downs or populating UIs from where you can select different options. So we'll see how to implement that in SQL in a minute. Specializations, right? Notice that we also have another stereotype, abstract, right? Which means something to us. What does it mean? Is that presumably programming languages would not be able to instantiate classes of this type. They're only meant for us logically breaking up the data structure into progressively more concrete concepts. Like a widget, that's way too abstract to have an instance of a widget. But all widgets should have a name, a width, and a height. Right? But as you come up with progressively more concrete things that can actually be rendered on screen, right? Then these are not abstract; these are concrete classes that inherit from the abstract, right? And they inherit the string, the names, the width, the height, to build something more complex like an image and a heading. Okay. Yeah, multivalued attributes like tags, keeping track of multiple tags or multiple strings. Associations. So associations, the generic um, um, capturing of association is just a line, and then verbs that specify the type of the relationship between authors and book or any two binary classes. Typically, the verb is written right next to the class, so that you can read it from any direction. You can read it from author is written. Book is written by the author, or the author writes a book. Right? You can read it in both ways. It's very common for documenting what the relationship looks like and how you would reify it. If you reify this, right, and then you might come up with an additional class or table that is called written by, right. Right. So roles should allow one to form a sentence. Yeah, an author writes a book. Multiplicity, where you use how many are participating in the association, 1 to many, 0 to many. Can a book be written by more than one author? Oh yeah, no. So this is just giving some examples of when you writing these diagrams, and you're interviewing your audience. They're not gonna understand our jargon of what we're using, how we're implementing it. So don't use any of the jargon that we are familiar with. Foreign keys and primary keys and inheritance or multiplicity. That's all jargon within our own community. But when we are interviewing our stakeholders, we would use just plain old common language. Association class, captured again with a dash. In old UML, you would capture it like a mapping table, like a mapping class. Right? But the new version of UML, you capture it using the dashed lines. What else? Aggregation with an open diamond, composition with a filled-in diamond, and that's it.